Hello, Azure Stackers, or Azure Stackists, or whatever we call ourselves. It's Pat Telford again. I'm going to talk to you today about hybrid applications in Azure Stack. And once again, I'm coming to you from my shed. It's a bit cold outside. It's 7 degrees outside and 10 degrees inside my shed because I haven't had my heater on for too long. That would be about 52 degrees in foreign heat temperatures. So if you see me turning blue in the middle of the presentation, you'll know what's happened. So one of the real values of Azure Stack is that it is Azure. So the power of Azure Stack really comes into play when you think about and plan for and design and deploy solutions where it's sometimes deployed in Azure and sometimes in Azure Stack, or solutions that make use of both the public cloud and your on-premises Azure Stack scale units at the same time. So we're going to talk about a whole bunch of things to do today. I'd like you to take away from this is not so much the nuts and bolts or the exact scenarios we talk about here, but just the possibilities. So there are a whole bunch of possibilities for combining Azure Stack as an edge solution in a workload with public cloud Azure. So just keep that in the back of your mind. I'm sure at the end of this session, you'll be able to imagine some use cases for your own customers or for your own use case. So we've talked a lot about the architecture of Azure Stack and a little bit about Azure itself. So the intelligent cloud idea is the thought that you can construct applications using computing that sits around anywhere in public cloud using a set of APIs and standard interfaces. And the intelligent edge, where Azure Stack sits, is some devices that are connected close to where the action happens. They're gathering information or processing and handling computing workloads somewhere that's relevant to you and your business model and your operations. I'm not going to go too much into Azure Stack because we've gone over this before, but the main things to think about are the scenarios for Azure Stack. There's an edge and disconnected scenario where you're trying to deploy a solution really close to the edge. There's regulatory or data sovereignty reasons for using Azure Stack. You don't want your data to move out into a public cloud data center somewhere. And then there's an application modernization opportunity. You're going to use the most current techniques for developing and deploying workloads in your environment. And the use of ARM templates, Azure Resource Manager, is a perfect example of how you can produce modern applications inside Azure. So there are several forms of hybrid. The first simplest form is that you can build things the same way in more than one cloud. And that's obviously true for Azure Stack. You can use ARM principles and ARM templates and the same APIs to deploy applications and workloads to the public cloud as you can to deploy to Azure Stack. There's another hybrid pattern where resources are spread across clouds. So you use public endpoints for connectivity, but parts of the solution are deployed in another cloud like Azure Stack. Or you might have connectivity across clouds. So I'm going to show you some examples of workloads where parts of the functioning are deployed in public Azure and parts of it are deployed locally in your data. So this enables a whole new set of applications. So if you imagine there are industries, there are opportunities to apply computing to problems that are in harsh environments where you want to get computing close to the thing that you're actually studying or modeling or taking data from. And Azure Stack offers new form factors while still maintaining that cloud sensibility and cloud compatibility. So here's a picture of our Azure Stack truck. It's got a ruggedized Azure Stack sat in the back, and it's got a drone or a set of drones that can fly around it and do mapping and inspection capabilities, send data back to the Azure Stack that's in the back of the truck, and then later on it can be connected back up to other services in public Azure to do more analysis on that data that was connected at the edge. There's also some interesting new form factors that could happen. I said this is the back of a truck. There's a ruggedized Azure Stack in there. So Azure Stack doesn't just have to be deployed in your data center. We've been talking about ARM before, so I'm not going to go into the details of Azure Resource Manager. There's another module for that. Instead, I'm going to carry on and talk about some patterns and architectures that we've built for in a hybrid scenario. So in order to kickstart the thinking and the playing around of developing hybrid applications, we've produced a few patterns. Set of 3 foundational patterns for Azure Stack. They're available on Microsoft.com, and I'm going to quickly run through here. These are like building blocks that are used to form either a hybrid environment for Azure Stack or parts of a hybrid application or workload that you deploy on Azure Stack. So the 3 of them are a hybrid connectivity model where you connect an Azure Stack up to the public cloud Azure. There's a hybrid model for continuous integration and continuous deployment, where you use deployment tools, in this case Visual Studio, to build your solution and deploy it and automate its deployment through Azure Stack and Azure. And a hybrid identity, where you can use a single identity to link together applications that are deployed partly in Azure Stack. So first, at a high level, here's the hybrid connectivity pattern. So the idea here is that you would deploy a virtual network in Azure on the right-hand side here, and another virtual network in Azure Stack, deploy some resources to each, but you want them to communicate and have connectivity. So you will deploy a VPN tunnel to connect up these 2 virtual networks so that they can seamlessly connect. So there's a step-by-step document that will guide you through this process in a standard manner. So basically, you're going to have instructions here for setting up the VPN gateway to connect those 2 in private and public cloud. The next basic pattern is hybrid identity. So how can you create an identity that's usable both in Azure and Azure Stack? In this case, the best way to have deployed Azure Stack is to use Azure Active Directory as your identity source, because that's an identity that's usable on both sides. If you did not do that and you're using ADFS, it's possible to use things like service accounts or maybe deploy your own internal Active Directory that spans both Azure and Azure Stack to do that. But with Azure Active Directory, this is very simple. You can create a user or a service principal that can deploy, manage, and connect resources that sit in either. So this service principal idea is shown in this slide. So you might want to take use of an identity in your application itself. So maybe this is the way that a website communicates with a database. It would use an AAD account to do that. There are, again, step-by-step procedures for implementing this. So it goes through creating the service principal in the portal of Azure and linking it up to Azure Stack using other tools and APIs to happen. And the third foundational pattern here is a hybrid continuous integration and continuous deployment pipeline. So this is what most people in IT will be familiar with now as a way to rapidly build, deploy, test, automate applications. So in the cases that are documented for this one, we use Visual Studio as the source. So the application developers will be using Visual Studio. They'll have some sort of repository. In the example, we're using Git as the repository, although other options are possible. And you set up your project for continuous integration. So it can be triggered. It uses Visual Studio and Visual Studio team services to deploy the application. And it can go either to the app service on Azure Stack or the app service on Azure. So this is a foundational piece for a DevOps pipeline build. And again, here's just a screenshot. This is part of the step-by-steps for how you would set this up in Visual Studio. You can see there's a trigger that will send this sample application, the Northwind Cloud Traders web application, both to Azure and to Azure Stack. And continuous deployment is enabled. So once there are new branches available in Visual Studio, they can get automatically deployed to both environments. And then testers can start running their automation. So here's what the tutorials look like. There are step-by-step instructions for how to do deployments of various. And the idea is that this would be a series of releases that describe how to conduct and build hybrid applications in Azure Stack. More detail about these. These are solutions as opposed to the building block patterns that I just described. So the first 6 solutions that have come out and are available on Microsoft.com, there's a hybrid DevOps one that builds on the CI/CD pipeline that I just showed you. There's cross-cloud scaling, which means you can use the power of Azure to bump up the performance or the number of resources available to your Azure Stack solution. There's a data sovereignty and gravity one where the front end is Azure and the back end is a database in Azure Stack, so your database stays on your data center. There's an interesting AI at the edge scenario where you want to conduct some AI operations and take advantage of the stronger machine learning capabilities in public Azure. There's a solution for geo-distributed applications for globally distributing between Azure and Azure Stack. And there's a tiered data solution for performing some analysis at the edge and additional analysis in the public cloud. I'm going to go through really quickly just to give you a flavor for them. So this is where you can imagine the solutions in a hybrid environment that are really powered by ARM and take advantage of that symmetry between Azure and Azure Stack. So in a generalized hybrid solution, it might look something like this. The users at the left take advantage of smart DNS in the public cloud, and they're directed to one or the other location, either Azure or Azure Stack. You can see that in the Azure solution section, there's a website and application, but there's no database. The database is only in Azure Stack. So we'll talk about these variations. In this case, the data is back, but the front end is distributed between Azure and Azure Stack, and the developers would use a hybrid continuous integration and continuous deployment pipeline to deploy the same solution using the same ARM templates to both sides of the house. So let's now look at each of those 6 solutions in turn. The first one is hybrid DevOps. So this is to allow you to use the power of the same tooling to deploy solutions to either one. So if you imagine we have a DevOps scenario, our application needs to go both to the app service in Azure, Azure Stack. The developer develops his code. He uses an ARM template. He checks it into his repo. The automatic deployment conducts build and unit tests, and then there's an orchestrated deployment live to both locations, Azure Stack and Azure. So the app server places at the same time. Here's a more complicated diagram showing that, but it's basically what I described. The Visual Studio developer has a Git repository, and his releases go to build agents on Azure Stack to deploy the solution and to a template on the Azure. The next pattern is called cross-cloud scaling. So this is exactly what it says. This is you need to scale your application, maybe at certain times of year, or if there's an unexpected load, so that you can accommodate that load. And you may not have the capacity to run everything in Azure Stack. So you can deploy it in a burst to Azure. You're still taking advantage of the fact that an ARM template can deploy to both places, and the user experience will be consistent across the 2 clouds. So this example here is a web application. You can see users normally attempt to access the web application. They hit Traffic Manager, so the smart DNS that's running in public cloud. It normally directs them to the Azure Stack instance, which is where you prefer them to run. There is something monitoring the Azure Stack capacity, how hot it's running, and that's an Azure function. That function can run either in Azure Stack or it could run in public Azure, but it's going to monitor the performance of your web app in Azure Stack. When it reaches a certain threshold, that function fires a trigger that tickles the traffic manager and also starts up some additional instances of your application running in public cloud Azure. So now the users will be delivered through the traffic manager, sometimes to Azure Stack, sometimes to an instance running in Azure. And that can be just spun up and down by the function based on. Here's a more logical diagram of it. So you can see the traffic manager, the build server for deployment, SSL is enabled, etc. And the magic here is most of the time your application is in Azure Stack, but you can easily burst it up to Azure to increase demand. The third example here, the third solution, is for data gravity. So this is where you have a requirement, a regulatory or a statutory requirement to keep data in your own data center. You may want to take advantage of the front end sitting somewhere else. So in this case, it's okay for the web application to be running in public cloud. You can take advantage of multi-region support, delivering users to the closest instance, all that goodness that you have in Azure, while still keeping your data in the background. So in this case, the user enters their information into an Azure-based web app. That web app would use a service principal, like in one of our foundational blocks, to connect to a database behind the scenes running an Azure Stack. And it would also go across a site-to-site VPN, one of those other foundational blocks that we talked earlier. So this way, the data in the database always stays in your database. Another interesting hybrid application pattern. Again, here's a little more logical exploded view. You've got a site-to-site VPN gateway. You can see the deployment of the web app, and you can see that the database server exists only on the Azure Stack part of the picture. So this is the most complicated solution that we've provided details for how to implement. It's called AI at the Edge. And there will obviously be a lot of variations on this that can do a lot of powerful stuff that combines the wider array and the more powerful AI functions available in public Azure with the ability to do some of that deployment at the edge in Azure Stack, so close to where the action is. So here's a quick overview of it. In the solution, the step-by-steps will show you how to build and train a model for machine learning in Azure, in public Azure. You can take that model once it's trained, export it, and take it across and deploy it to a Kubernetes cluster running on Azure Stack. So the basics of that model will now be available to consumers inside Azure Stack. You could then disconnect your Azure Stack and take it away to the edge or wherever you're going to have inputs. The inputs are scored against that model, and there are initial insights from that scoring placed into a queue. That queue is accessed, and any insights that are compliant, so any data that you will allow to be exported back to the public cloud, can either right away or later, when the Azure Stack is reconnected, be sent back up to the Azure interface where global insights are available, and then more training can happen on that machine learning model, and it's a virtuous cycle that can then be added back to Azure Stack. So one of the things that's important here is that function, that number 5 function there, it could be used to maybe sanitize some of the data. So if there's personally identifying data or something that you don't want to be visible globally in the model, but you want it to be retained in the Azure Stack raw data, it can be deployed and make that decision for you about which data is allowed to flow up or down. So again, here's the exploded picture. It's got a lot more detail about where Visual Studio sits, all the components that are deployed into Azure Stack. You can see Docker's there, deploying the Kubernetes cluster, storage, the function, the machine learning experiments, etc. on the Azure side that the data scientist would be taking control of. The next one to talk about is Geo applications. So this is where you want users to go to the most appropriate place to connect to the application. So the example here is a web app. So you can see there are multiple Azure Stack instances. And as you know from some of the previous lessons, each one of those is like its own cloud. There's one in Africa, one in the EU, and then there's a general example of that same web app deployed into public cloud Azure. Again, we use Traffic Manager at number 2 there to send the user to the most appropriate spot, and they may end up in either an Azure Stack closest to them or in the public cloud. So again, this is just a little exploded view of what I described earlier. And the last solution here is called tiered data for analytics. So this is where you consume data at the edge or close to where the action is, but then you want to do some additional post-processing on it, and you want the power of Azure to do that. So the data comes into Azure Stack, sits in the storage account, and this is just our sample implementation. There are other ways to have an application that works like this. So the data is sitting there in Azure Stack. There's a function that sees data come in, and any inferences or any insights available from that data can just be shown right away to the user. So this might be monitoring the data that's coming in. How much data have you collected? Maybe you can do some initial intelligent querying against it. However, you want to take advantage of some additional services on the Azure side. So the function processes, parses the data, makes it available for further processing outside, and another function takes it, sends it up to Azure, and then you can have global insights. So maybe you're making machine learning work against it in public Azure. So as a user, you might go to that number 3 web source in Azure Stack and get some initial insights about how the data capture is going, and the final analysis, you'd go to another web source in public Azure and collect it at the number 6. Again, a little exploded section of detail for what's actually being deployed in each location. So I mentioned these are 6 solutions that we have available on Microsoft.com. Each of them has a tutorial that goes with it. So there's an actual reference sample solution available that you can, I'll give you an example of what they look like. So here's one of the more complicated ones. This is the AI at the edge. So the article starts out with a set of explanation for what's going to happen, what you're going to use, and why. And then there are literal step-by-step. So here's an example of the work that you would do at the start to train the model in Azure before exporting it and deploying it into Azure Stack. Step-by-step with screenshots. You'll create an Azure machine service, you'll train the model, and then you'll export it. And then the next step, or a further step later on, is to deploy that model into Azure Stack. You're going to build a Kubernetes cluster, deploy the cluster, and send the model cluster so that it can handle the AI function at the edge. I mentioned there's a function that cleans and sends the data from Azure Stack back to Azure. There's complete descriptions for code to that function. And each of those 6 solutions has a step-by-step sample just like that. So you'll be able to follow through and build a reference application that can help you think about how hybrid can work between Azure. So as a developer, here's a few things. You will use standard tools to do this. There are a selection available. You can use Visual Studio. You'll use Visual Studio Cloud Explorer to point yourself to each environment. As always, you can use PowerShell or the command line interface or SDKs to poke either Azure or Azure Stack in a similar fashion. And you can use application insights and log analytics to examine and monitor and watch how it is operating. Now, there are a few wrinkles to work through. So we know that Azure and Azure Stack are not identical. They both use ARM, but not everything available in public cloud is available in Azure Stack. So you have to be aware of any special wrinkles that you use in your ARM templates that aren't available in Azure Stack. You obviously can't hard code your deployment endpoint. If you want to point your ARM template at one or the other of the public or Azure Stack clouds, you'll need to use variables here. There are some assumptions that you can't take, and obviously you can't try and deploy an ARM template that contains a not available on Azure Stack. So there are a few things to help you here, some guardrails. So in the Git repository for Azure Stack tools, there are 2 things that you should look at. One is a template validator. So it can rip through an ARM template and decide if it's applicable for deploying as is on Azure Stack. Like, are the API versions all correct? Are the types of VM sizes that you're using available in Azure Stack, etc. So it's like a way to look through your ARM template after it's been built and see if it's appropriate, and if not, where you might need to correct it. The second thing that's really useful is there's a policy, so an ARM policy that you can deploy into Azure. And what a policy does in Azure is it sets some restrictions or limitations on what you're allowed to do or not allowed to do. It's often used for controlling what developers are allowed to do in Azure to constrain them a bit. But in this case, it's going to constrain the developers to only be able to deploy something into Azure that's also available in Azure Stack. So you can create a section in your subscription with the policy applied where you would build your Azure Stack section of your application. So the hybrid part that sits in Azure Stack. Then your developers can work completely in Azure. They might have one unrestricted section where they can deploy their regular Azure side parts of the workload, and another section that's got this policy in place, which will be emulating the part or the environment that they can deploy into for Azure Stack. So those things are interesting. They're updated. They're available on the Azure Stack Tools repository in Git. So here's a few things to think about as you're building your application. So the endpoints, you need to point the different parts of your solution to Azure Stack and Azure. So each will have its own endpoint. Each is an independent deployment of an Azure cloud. So in the public cloud, you've got normal places that you go to connect to. In your Azure Stack, you'll have a different URL essentially that you'll be connecting to. And as another example, there are other clouds available, like the China cloud or some of the sovereign clouds around the place. So they again have different, you'll be connecting to multiple environments. So here's an example of a section of an ARM template that references multiple endpoints. You'll just have to parameterize them and use them in your ARM template. And keep in mind that one ARM template can target multiple endpoints. So you can build a template that can deploy the whole solution, partly to Azure, partly to Azure. So here's a quick demonstration about how you can get the details from Azure Stack using PowerShell. So this is the PowerShell command line interface connected up to get information. So we're using the get Azure RM environment command to pull out the URLs. Now we want to find which of those URLs is pertaining to Azure Stack specifically. So this is just filtering down. So you can use this in your ARM template to figure out where to go to. Okay, so that command has teased out the details of the Azure Stack Cloud instance. You can see in there, you've got the URLs that you need to connect to for the API, for the portal, etc. So that's just an example of how you can use commands and PowerShell scripting with your ARM templates to look up information about your Azure Stack environment in the same way that you would use it to look up information. So the moral of the story here is that you want to use variables and templates and variables and parameters in your ARM templates to let you point successfully to either public or Azure Stack. You can see instead of using the hard-coded URL there, you can instead put in some variables. You're going to get the storage account name. You're going to get the endpoint that you're connecting to in Azure Stack. So if you use those variables in your template, you can then use Visual Studio to fill in those variables and pass them as parameters later on down in the ARM to point yourself to the right place. We talked about one of the building blocks earlier is the hybrid identity. So you can authenticate between parts of your application using a service principal. So you'll create a service principal in the Azure Active Directory, and you can then use that to deploy your solution into the multiple places and within your application to allow connectivity between different parts of your app that need to authenticate to each other. API versions are different between Azure and Azure Stack. They are close, but Azure Stack will always lag behind because we wait for code with the APIs that backs the APIs to be available in Azure first, and then that gets ported down to Azure Stack and updated in one of the monthly updates. So your application, your script, your ARM template needs to be able to handle the multiple versions. And we're going to talk about how we do that. So in this example, you can see that there are numbered by date API versions available in Azure. So in the API version section there, you can see there's a 2016-0330 API version for this virtual machine section of an ARM of a connection. You need to specify the API version in your ARM template. There's some ways to genericize that, which we'll talk about in a minute. But you can see that in here, this ARM template section has an API version included in it that should be used. And they correspond maybe to features that are available. In this case, we're showing DHCP options as an Azure feature, and it may have different options depending on the version you're using. So this brings some challenges. Because the API versions are different between the two clouds, you may have a bit of trouble specifying which API version to use in your ARM template. And if you're using an SDK, it's time consuming to figure out which libraries and modules you should. And again, the API differences between the cloud services that you're talking to. So the solution here is a thing called ARM API profiles. So a profile is a set of namespaces or a set of capabilities in your cloud and their API versions. So you don't have to be as precisely specific in putting the API version into your ARM templates. You can use some shorthand to say, hey, I want to use this whole set of API versions for all the stuff I'm going to do later on in my ARM template. So this isn't just for the ARM templates itself. You can use it in PowerShell commands, in the command line interface, and in the SDK. And Visual Studio is smart enough to understand how to use the API profiles. So it's a general way to interact with clouds without having to be really finely grained about which API you're going to use. So there are a number of shorthand ways to select and identify which profile you're going to use. There's always one called latest. So that's going to use the most recent version of the APIs that are available in Microsoft Azure. So your application may specify, hey, I just want to use the latest APIs, and hopefully they'll be backwards compatible and it'll continuously work over time, but able to take advantage of the latest features. There are also dated profiles. Those are more applicable to Azure Stack, and we'll go into detail about how they're defined and when they come out. So the latest version is available in Azure. It's the most up-to-date version of the APIs. You just tell your command or your ARM template to use that. There will be a year, month, and day profile that's available, and it's sort of in between the cutting-edge version of the APIs and a more static version. And the more static version is called year, month, day hybrid. That will come out twice a year, and it focuses on consistency and stability between multiple clouds. That's the Azure Public Cloud, the sovereign clouds, and Azure Stack. So you can see the benefits. Instead of having to drill down into each API version for each resource that you're calling, you can say, hey, I just want to use this profile for my whole deployment. And it works across all. If you want to use this in Azure Stack, here's an example of the command to select a profile. So you can see we're going to have the CMD let use Azure RM profile, and we're going to specify one of those longer-lived collections of APIs. It's the 2018-0301 hybrid model, hybrid profile. And that's just a way of setting the scene for all the interaction you're going to have with Azure Stack from that point on. You're explaining, hey, I want to use the profiles that are included in this, or all of the APIs that are used in this profile. So some things to think about in your ARM template. You should use dynamic endpoints. So you're not going to hard code which cloud you're talking to. You're going to parameterize the locations of things that you're connecting to. And you should be flexible about the VM sizes and OS images, because not all the sizes or images that are available in public Azure may be available in Azure Stack. So there's an example here that's on GitHub. It's one of the quick start templates. And you can take a look at that to see how you might form a nice ARM template that connects to both Azure and Azure Stack. In our examples, we have Visual Studio as the deployment method. That's worth taking a look at, even if you're not committed to Visual Studio. When you go through the solution samples, some of them that have continuous integration and continuous deployment will use the example of Visual Studio as the deployment tool. Obviously, all the deployment tools that are out there in the market can be adapted for DevOps. So you may be using other tools beyond just Visual Studio, but it's a good place to start if you're just looking at hybrid scenarios for the first time. You'll be familiar with the Azure Stack tools from some of the earlier modules. You'll be using that. And authenticating with a service principal means that you can point at multiple clouds and still use one Azure API for it all to be glued together. So here's a few things that you should take away from this. You can imagine some of the broad possibilities for deploying hybrid solutions. This is one of the real superpowers of Azure Stack. It lets you use the same tools, the same techniques. Developers will be familiar with deploying stuff the same way to Azure Stack as they have done in Azure applications. The patterns and the building blocks that I showed you combine into these services, these solutions. So take a look at those on the Microsoft.com website. There will be some links to that in a couple of minutes. And this is your opportunity to express the value of Azure Stack and how developers can make nice applications. So here are some of the resources. You can look at the links there. There's a nice selection of aka.ms links. It includes the tutorials, the application samples, how to set up your Azure Stack development kit if you want to test this without a full multi-node Azure Stack environment. Thank you again for watching this module of Azure Stack. You're almost at the end of the set of recordings now. So I hope you've enjoyed the series, and let's move on to the next topic.